Okay, so yes, so I'm Brian Matthews. I'm the DAFNI project lead, as Marion introduced me. Yes, I'm going to talk about DAFNI. I'm going to mostly introduce DAFNI, but also try and place DAFNI in the digital twin environment and talk a little bit about what we're thinking about and doing with ontologies. So I like to start with this quote: "Data is now important to UK infrastructure as concrete or steel," which was said by Sir John Armitt when he, on the National Infrastructure Commission, when he appeared at our launch event just a year and a half ago now. And in this report, Data for Public Good, he quotes, he comes to the conclusion that a national digital twin would bring together an individual infrastructure models capturing data on national infrastructure and interdependencies between infrastructure systems, supporting development within the infrastructure sector in data-driven economy. So a call to arms to build some ecosystem of national digital twins as a driver for infrastructure development and economic development into the future. So there's obviously been quite a lot of work done on this, and I won't go into what digital twins are, that's been said already, but to build this ecosystem, well, a single national digital twin would not be feasible. We're looking at a federation operated by different organizations and coordinated together, and with one common information, within a common information framework to allow that effective information management and sharing between digital twins. And we've seen a lot of work in this area. So CDVB in particular, with its Gemini principles and now its information management framework, is kind of exploring how we might develop this idea of this national digital twin ecosystem. But of course, that leads to a lot of technical challenges. And particularly, we've got more data, more models, which we need to operate together, high resolution. We need more and more computing resources. We need to be able to scale up, which is a significant challenge. And then beyond that, we need to be able to integrate data and models at different scales, between an individual piece of equipment right through to a site organization, through a region, or right up through the whole country. So we need to be able to do that coupling between different models, and then different sectors. We've got water, energy, land use, digital transport, all these different areas where we are building digital twins. We need to bring those all together, but also link through to the data from the natural environment and from the economic and social environment, so we can look at the impacts and both ways on the impact of these things on the infrastructure environment, but also the impact, the feedback into those environments, impacts on those environments. So we've got a major data and model integration problem here, and we need to capture these interdependencies and integrate and couple across scales and across sectors. So it's a significant challenge. So this is where we hope DAFNI comes in to help. So DAFNI, which is the Data Analytics Facility for National Infrastructure, the idea is to provide a computing platform to improve decision making for national infrastructure. This has been a 4-year program now, nearly in the final few months, of an £8 million investment from a program called UCRIC, the UK Collaboratorium for Research and Infrastructure for Cities, to build a research platform to support the scaling up and the coupling of research across different sectors. And this involves 12 universities and ourselves, STFC, the Flappin Laboratory in Oxfordshire. As developers and hosts, we are a large scientific institution working in research sector whose job is to provide infrastructure and support for UK research, including computing research. So that's where we come in. So what is DAFNI? Well, DAFNI provides a hybrid high-performance computing platform, but so with some reasonably significant computing resource available, but on top of that, we are building a software stack, provide a secure repository for heterogeneous national infrastructure data and the models associated with that. and that's intended to be a collaborative platform for research and development. So you can access those models, you can run those models, you can link those models together to explore the scenarios that you're interested in. And then beyond that, it becomes a place to make data models available for long-term accessibility. So there's a legacy aspect. So people can, after projects finished, after data sources might disappear, data collectors might disappear, where there's a place where data can still remain and those models still remain accessible and for use. So this is a kind of very quick tour of DAFNI functionality in a single slide. So there's a login with a security model behind that for managing users and groups of users to make data models released to the right people, as open as possible, but as restricted as necessary. And then there's a way of uploading data into that. So we can provide data resources into that. You can let people upload their data, can find data in a data catalog. You can upload models and you can find other people's models that are made available to you, and then build them into complicated workflows to couple them together and do things like iterate them or over them, or build visualizations from them, and then there is that visualization engine at the end. So this is the functionality we've got. It's not quite all there, but it's getting all there. With certainly the visualization parts are some of the ones we are now currently finalizing. So and to give an example of how we used it, well, Digital Twin Talks like an example of what we're doing in digital twins. So this is a pilot that we've been doing over the last few months in collaboration with the University of Sheffield, Christian Giennes and Daniel Coker, to build a traffic twin. So the University of Sheffield has an urban observatory around the city, 640 sensors of traffic flow, uploading information about the traffic in those locations every 5 minutes. What the product is trying to do is trying to build an AI-based model, which has then been hosted on DAFNI as a central point, which updates the real time for each sensor, and then predicts the evolution of the traffic in a sort of 30-minute period ahead. To give us a digital replica of the traffic flow in Sheffield, identify with areas where congestion will occur, so you can then potentially do something about that by altering offering the traffic lights or whatever. So we are making experiments in digital twins as we go. So how does this affect the National Digital Twin? Well, DAFNI provides a data hub, so we can bring in different data sets together, we can share them, we can integrate them, we can keep them for long term as a trusted, secure place to access data. And we've got a relatively straightforward metadata framework for bringing data together based on a metadata model called DCAT2, which gives us common search and access. But if we're going to really integrate data together, we need to bring together different sources. So we need to be extensible to the different sectors, water, energy, transport, and also the environmental and social and economic data that we're related to. So that's where we want to build an information management framework, an ontological framework for data to do that. And we started exploring with Liz Varga, who's on the call and speaking later, to define that ontological framework we're going to add and extend to our model.
Just a half a minute to go, Brian.
Oh, I've got a minute and a half, I think.
Yeah.
Okay. And then just quickly going through this, we also have model execution environment, so people can upload their own models. Models are Dockerized, containerized using Docker, so that gives them sort of independence from the platform, but nevertheless we can run them in independence of programming language, but we can bring them all together into one place and link them together, which is a really powerful feature and gives us that repositories of models for available. And then we can link those together to couple them into workflows and then execute them together, chain together. And an important part here, I think, are the connectors, transformers, and filters that you would then do to do the data between them. And I think that's again where the information management framework comes in as a way of doing that integrated database to bring them together. So my final slide. So DAFNI offers a platform as a to support research collaboration in developing a national digital twin, HD platform for research and research, supporting the research community, and also technology transfer, how to bring these models and make them available to a wider audience, and also people who aren't necessarily experts in running models. Data sharing and common infrastructure, scale and copper models in those deliverable principles. We're still work in progress. There's still a lot of work to be done. We're doing pilots, we're doing experiments on the way we handle data. And as I said, working with Liz on providing the data ontology support. So thank you.